This lesson is part 2 of lesson 4.1 from our 6th grade Math and Focus textbook. So it comes from the extra practice problems where previously we were just comparing two units in ratios and writing them in simplest form. Well, the back side here gets a little more complex. We get to again return to conversion with some similar units, and we also need to think about kind of the context that they're asking for. So I'm going to start here with number 10. It says Mr. Toneman buys 1 2-pound lobster and 1 pound 4 ounces of shrimp. Find the ratio of the weight of lobster to the weight of shrimp. Well, I can kind of picture this, and I'm going to encourage you to try maybe a bar model approach on a few of these, just so that we're kind of getting familiar seeing that in ratio format. So the first thing I know is that Mr. Toneman is buying a 2-pound lobster. So I'm just going to call that L, and I'm going to show you here that he has 2 pounds. Next it says that he buys 1 pound 4 ounces of shrimp. Well, that would be even smaller, wouldn't it? It's not enough to write 2 pounds, so we're going to write 1 pound 4 ounces, and we're going to call that S for shrimp. Okay. Next they asked me to find the ratio of the weight of the lobster to the weight of the shrimp. So this is my clue. Lobster comes first, 2 means compare, and shrimp comes last. Well, that's not too bad. That means L to S, or lobster to shrimp. That means 2, oops, I just got myself in trouble here. I better label that because I noticed we're working with some different units. That means 2 pounds, easy for me to say, compared to 1 pound 4 ounces of shrimp. Notice I have to use the units on this side right now because I'm in unlike units. I have to make sure that I get everything to be equivalent or the same size units in just a moment with some conversion. So this is where I would encourage you to break out your planner again. Maybe look at page R8 where you can see some conversions. I actually went online and I found this table that might help us because it shows me pounds and ounces. It's underneath weight and mass. So underneath weight and mass, it says that 1 pound is the same as 16 ounces. What that really means is I could turn all of these really gigantic pounds into some really tiny ounces. I'd have to multiply though. I'd have to multiply by the 16 ounces that I'd find in each. So let's see what happens when I simplify this a little bit. Well, what is 2 times 16? Hopefully you'd say 32. And this is ounces now. We've made them the smaller unit. And now I would have just this 1 pound times 16 ounces, because there are 16 ounces in 1 pound. So 16 there, plus 4 extras. That really gets me 20 ounces. Oh, good, I have the same units, which actually means I probably could write this in simplest form. Well, once these units match, I kind of cross them off and say they're not that important any longer, and I divide by the greatest common factor. What's something that divides nicely into 32 and 20? I'm thinking 4 might work. 4 goes into 32 8 times, and 4 goes into 20 5 times. Looks like I'll get a ratio of 8 to 5. This does make sense to me, by the way, because when we look back at our lobster and our shrimp, we notice that the lobster is a longer bar, also meaning that it has a greater weight or mass. All right, next we're going to take a look at number 11. This one is kind of challenging unless you do all your conversions first. So I'm going to show you how I think we should approach something like this. So number 11, Taylor is making punch. She mixes 1 gallon of orange juice, 3 quarts of cranberry juice, 5 pints of apple juice, and 8 ounces of lemon juice in a large pitcher. Find the ratio of the following amounts. Well, I know for a fact, I'm reading a lot of different information in here. For instance, there's 1 gallon of orange juice. Okay, that's pretty important because they're measuring gallons. Next they go on to measure 3 quarts of cranberry juice. Well, another different measure. I'll grab a different color here for another type of measure. Now they have 5 pints of apple juice. And last but not least, they have 8 ounces of lemon juice. Well, make up your minds. What kind of unit should we use here? So the best thing that I can think of in this situation, before I can even start writing ratios, is to find like units. We really want to make them the same. So I'm going to break those pieces down over here. So this will be my ingredient list. And the first ingredient was orange juice. Remember, if I look back, there's 1 gallon of orange juice. I'll write that down. But that's not super helpful. What is the smallest unit that they gave me to work with? Quarts are smaller than gallons, and pints are smaller than quarts. And, ooh, ounces are the smallest. So how could I turn my gallons into ounces? Well, we might have to take a quick minute. We might have to find a tool that will help us. Maybe a conversion chart. So let's see if I can find something that will work. Looks like I might have a little erasing to do here too to make this fit. Oh, this is more like the ingredients or a conversion chart that you'd see in the kitchen. So it's talking about capacity. Well, I want to turn my gallons into ounces. So I do see gallons here. It says how many gallons, or let's see here. It says how many pints are in a gallon. There are 8 pints in a gallon. Oh, what else does it tell me? It tells me how many fluid ounces are in 1 pint. This might be helpful. So I'm going to grab a couple pieces from here. I'm going to grab this piece where, oops, I'm going to try anyway. Oops, if you're on a pen. I'm going to grab this 16 fluid ounces goes to 1 pint. And I also need to remember that there are 8 pints in 1 gallon. So maybe what I do is I'd say this equals 8 pints. But I'm trying to get to ounces. So now this would be really helpful. I don't just have 1 pint, I have 8 of them. And inside each pint, there's 16 fluid ounces. So really I need to multiply times that smaller unit, times 16 ounces. Well, I could think this in my head real quickly. I know 8 times 10 is 80, and 8 times 6, 6 times 8 is 48. So I have 80 plus 48. Looks like I'm going to get 128 ounces. Whew, done with orange juice. That was a challenge. Next, we're going to grab the next ingredient from our story problem. It talks about 3 quarts. Okay. Next, I have 3 quarts of cranberry juice. I'm going to write CJ for cranberry juice. I'm going to write down that that's 3 quarts. And we're going to see if we can turn that into ounces somehow. So I'm going to look up here at my conversion chart, and this one's really nice because I notice right here at the bottom, 1 quart goes with 32 fluid ounces. I don't have much more to do. I can just write 32 ounces. Oh, okay. Cranberry juice, you're all set. The next thing I need to look at is 5 pints of something. Well, what did that belong to? Oh, apple juice. I'll just call that AJ for apple juice. And remember, it was measured in pints, so I'm going to write 5 pints here. And my goal is really to get all these units to be the same. Ounces, ounces, and more ounces. So if I have some pints, we already marked something like that earlier. I know how many ounces belong in each pint. 16 belong to each. Well, if I have more pints, I'm going to have more ounces. So I'm going to multiply by 16 here. Well, 5 times 10 is 50, and 5 times 6 is 30 more. Looks like 50 and 30 will get me 80 ounces. We're using quite a bit of apple juice, right? 5 pints. Oh, I've got myself a little bit worried here. Yeah, and this is probably good that it caught my attention. I was expecting the 5 pints, because they're a smaller unit, to be fewer ounces than the quarts. And when I looked here, I said, oh, that's not the case. It feels like I did something funny here. I took a shortcut that I should not have. In fact, those 32 ounces belong to each of those quarts, don't they? So I'm actually going to have to do a little multiplication here. I'm going to actually have to say, back a step, take that cranberry juice times 32 ounces in each. Oh, this is looking better. 3 times 30 is 90, and 3 times 2 is 6 more. Okay, 96 ounces. This looks reasonable. I'm going from the greatest quantity to a smaller quantity as I move down my ingredient list. Okay, better. All right, next up, it says 8 ounces of something. Well, that's lemon juice, so I'm going to call it LJ, and I'm going to write down 8 ounces. And my question to you is, would I need to convert that, or is it already in the form I need it? Oh, if you take a look, it's already ounces. We can leave it alone. So these are the pieces I'm going to use here. The ounces that are with each of these ingredients, okay, are over here on the right, and I'm going to kind of highlight them just so that I make sure I grab the right information. And again, the ingredients, I just kind of shortened. I used shorthand here a little bit to try to help you see like a quick way to organize things, and I think it will work. All right, part A, we're ready. It says, find the ratio of the following amounts. We want to write orange juice to apple juice. Oh, that means OJ to AJ. So I'm organizing, I'm showing you what I think they're asking for in the order that we need it. So I move over here across and I say, oh, orange juice, that's 128 ounces. My apple juice, I'm going to go over here and change it to my ounces. I'm going to use 80 ounces for that. Now this is not a final answer because this could be simplified. You notice the numbers are relatively big, so we have to think of what would be good to divide into both. Maybe you're not sure at this point, so maybe start with something like 4. 4 goes into both. Let's see what we get. 4 goes into 12 3 times, and 4 goes into 8 twice. I'm going to get 32 from the first term, and 4 goes into 80 20 times. Oh, I'm not there yet, but I'm close, aren't I? So what could I divide nicely into 32 and 20? In fact, I think we saw that on the first side of our worksheet. Looks like 4 goes into 32 8 times, and 4 goes into 25 times. For part A, we get a ratio of 8 to 5. We need to try this again, but this time we're going to try it with some different ingredients. So if you take a look, they're asking me to find cranberry juice compared to apple juice. So I'm going to write that out, CJ compared to AJ. And we're going to grab our numbers, not from the original problem, from all the conversions that we did across the way. So CJ is sitting right here. 96 ounces goes with cranberry juice. And the apple juice is the second thing that they asked for, so it's going to be my second term. Oh, 80 ounces, I see. Not a final answer, so I could probably simplify this one as well. I need to think of a number that will divide nicely into 96 and 80. And off the top of my head, I'm seeing maybe 8 would work. 8 goes into 96, well, it goes into that 9 once with 1 left over. So then 8 into 16 goes twice. And if you don't believe me, you can do some long division. Next, 8 goes into 80 10 times. Oh darn, I'm not there yet. I see that I can simplify one more time. These are both even, so I'm going to try dividing by 2. 2 goes into 12 6 times, and 2 goes into 10 5 times. If you notice, this is simplest form. This is actually part B. Kind of running out of space here. These are kind of squashed together, aren't they? But part B, I get a ratio of 6 to 5. There's more cranberry juice than apple juice in this problem. We want to continue the same strategy for the other problems, or the other parts of problem number 11 here. So I'll do one more with you and then see how you're able to finish that up on your own. So next it says apple juice compared to lemon juice. So I'm going to write, they want apple juice as my first term, lemon juice as my second term, and I will show you what that's the same as. So off to the side here, notice I'm not going back to my story problem. I already converted everything over here. Apple juice gets 80 ounces. 80. And lemon juice, that's down here. That got 8 ounces, didn't it? 8 ounces. And it's not a final answer because, again, we can simplify. What's something that divides nicely into both 80 and 8? I hope you are saying 8. 8 will work. 8 goes into 80 10 times, and 8 goes into 8 just once. 10 to 1 is my ratio of apple juice to lemon juice. This same process continues for part D and part E. You just have to pay attention to the order and then make sure that you simplify when you're done. And if you decide to simplify by something that's not the greatest common factor, like right here I divided by 4, I just had to divide again. That may happen to you, unless you find the greatest common factor of, say, 16 or 16 here. Oh, I'm noticing a trend. I'm going to fast forward to these bottom problems with you. I'm going to ask you to take a look at ratio in another way with a bar model. I'm not sure if I need this right now. I'll slide that off to the side. All right, so for number 12, we have Hamsa and Liam. They're baking 108 oatmeal bars. Hamsa makes 20 more than Liam. Find the ratio of the number of oatmeal bars Hamsa bakes to the number of oatmeal bars Liam bakes. Oh, I know how much they make all together. This is a total. I'm going to box that in and call it total. I'm doing some decoding here. I'm trying to find the important information. Now, if I picture this, wouldn't it be awesome if they both made the same amount? But they don't. It says Hamsa makes more, 20 more. So I'm going to go ahead and draw a bar for Hamsa and a bar for Liam. Notice I'm kind of using my shorthand, my shortcut here, and that's okay. So I know this first bar has to be a little bit longer. It has to be Hamsa. It says he made 20 more bars than Liam. And the next bar has to be a little bit shorter. It has to be Liam, and he didn't make as many, did he? Okay. Well, if I know Hamsa made 20 more, it's kind of like saying, well, if they had made the same amount, Hamsa would have stopped right there. But he made more, didn't he? He has 20 more sitting right there. So his bar is a little bit longer. Well, don't forget, I also know one more piece of information. I know the total number of bars that they made. Altogether, they made 108 oatmeal bars. Well, now the real question is, how am I going to figure out what the missing piece is in each of these? Well, if I could take this 108, couldn't I take away 20 and see what's left? That might be a really good idea. I could take the total and take away that 20 that was extra for Hamsa, and it looks like with a little regroup, you're going to find 88. There are 88 bars left between Hamsa and Liam. So right here we're talking about 88 between the two of them. Well, if this was true, couldn't I take that 88 and kind of split it in half? I don't worry about this 20 anymore. I already subtracted it a minute ago. Isn't it like saying they each got the equal part here? They each got half of those 88. So I'm going to take that 88 bars and I'm going to divide it into two groups. Well, what would land in each group? Half of 88 is 44. Oh, 44 in each group. That means 44 sitting right here, and that means 44 sitting right here. Next, they asked me to go ahead and write a ratio. I'm really ready to do that, I think. And it says, write a ratio for the number of bars Hamsa bakes to the number of bars that Liam bakes. Oh, okay, I'm ready. Hamsa to Liam equals. Well, the first number has to be Hamsa's. Notice he had 44 here, but 20 more. How would I figure out that total to write for Hamsa? Oh, this looks like addition. 44 plus 20 gets you 64. And next it talks about Liam. Liam is at L. So I'll come over here and look. Oh, 44. That's his total. So I'm going to compare 64 to 44. This makes sense to me. Hamsa's bar is longer. It says that he made more. This is not a final answer because with all good ratios, when you can simplify, do simplify. So what divides nicely into both of these? I know 4 will work. 64. Let's try some number bonds real quick. Isn't that the same as, let's see here. I'm trying to think of something nice that will work. 20 plus 44 more. Just like the bar model showed us. So 4 goes into 25 times. 4 goes into 44 11 times. So 4 goes into 64 16 times. Or you could use long division to get there, of course. 4 goes into 44 11 times. Double check, is this in simplest form? Yep, 11 is a prime number, and if it doesn't divide into 16, I guess we've got it. Final answer. All right. This next problem, number 13, is a real challenge in my opinion. It's taken me, I don't know what, 6 years on campus before I can just do it the first time through and usually get it right. So let's hope that's the case tonight. Anyway, last night on my answer key, it went okay. Number 13, 1 pound of swordfish costs as much as 1.5 pounds of salmon. Well, let's just stop right there. 1 pound of swordfish costs as much as 1.5 pounds. Okay, it's a comparison. I want to compare these. So the first thing I have is swordfish. I'm going to show you SF for swordfish. I'm going to show you 1 pound. Might label this right here, maybe call it 1 pound. LB is my abbreviation. Next I need 1.5 pounds of salmon. Remember the cost is exactly the same. So it's kind of like saying 1 whole and 1/2 more. This would be 1.5 pounds of salmon. I'll call this just S for salmon. And call that 1.5 or 1 5/10 pounds of salmon. All right, well let's read on and see what they tell us. Mrs. Ortiz pays $39 for 2 pounds of salmon. Well, she's buying more salmon. And 3 pounds of swordfish. Okay, let's stop right there. She wants 2 pounds of salmon, so the S is here for salmon. She already has 1.5 in my bar model. She'd only need a little half more, wouldn't she? To be able to get to 2 whole pounds of salmon. Now she needs 3 pounds of swordfish, so I'm going to kind of stretch this 3 pounds out and see how that looks. If I'm drawing these to scale as close as I can, you might notice that in this comparison right here, this 1 whole pound compared to this 1.5 pound could be broken down kind of similarly. If I broke these into halves, 1.5 is the same as 3 halves, isn't it? So I could break this whole bar into the same size pieces. Next, if I decide to show you that it takes 3 parts to make 1 pound of swordfish, it's going to take 3 parts to make another pound of swordfish, and 3 parts to make another pound of swordfish. Now if you dig back in, she pays a total of $39, so the total for my bar model goes along the side, and I want to figure out how much each little piece is worth so that I can give you a ratio in just a minute. So if $39 belongs to all of these little tiny pieces, which I've now broken into little halves, if you will, how many parts do I need to break it into? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to divide this 39 into 13 parts, or oftentimes we'll call it units. Well, if you know your facts of 13, you might say 13, 26, 39. I know it goes in there 3 times each. So $3 goes in each little box. $3 in this little box, 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 and I could continue that idea. I think I have enough information to be able to answer the question. It says, find the ratio of the amount of money Mrs. Ortiz pays for Swordfish compared to the amount of money she pays for salmon. So, final answer over here. Try to find some space for you. Maybe get out some lined paper if you're fighting with it like I am. I want swordfish to salmon. So let's go back to the swordfish. Notice I have 1, 2, 3, 4, 5, 6, 7, 8, 9 units. 9 units times $3 in each. And for the salmon here, I have 1, 2, 3, 4 units times $3 in each. I can really multiply these, and that will help me figure out how much each part of this problem cost. Well, 9 times 3 is 27, and 4 times 3 is 12. The swordfish is more expensive, and it also makes sense if you look at your bar model, it's quite a bit longer, isn't it? And so I'm going to get an answer of 27 to 12. I might ask you, is that a final answer, or can we put this in simplest form? Oh, and actually, yep, they do ask me, I wanted to double check, they asked me to find the ratio. So this ratio idea is good. If they actually wanted an exact amount of money, I could say $27 for swordfish, $12 for salmon, but they don't. They asked me for a ratio, so I can write my ratio in simplest form. What number divides nicely into 27 and 12? Hopefully you're thinking 3 will work. 3 goes into 27 9 times, and 3 goes into 12 4 times. My final answer is a ratio of 9 to 4. The swordfish was more expensive. It took 9 times as much. Well, that's not quite true, but it's a comparison of 9 compared to 4, or 9 to 4 with the price. Meaning there are 9 units over here, 9 of them, compared to 4 at the bottom for the salmon. Alright, these problems are extremely challenging. Something that will appear on the test in this unit will be problem number 12, something just like it. That is something that you should expect to see. The others, well, those are kind of stretching your thinking and challenging you with those conversions and trying to show maybe a comparison bar model. That ends our lesson, lesson 4.1, and next time we'll do a video on equivalent ratios and looking at simplifying and using division, and also finding equivalents by using some multiplication.